I'm Anil Kumar, and in this video we'll explore how to solve inequalities of combined functions. To start with, I've taken a very simple example. We'll consider functions f of x equals to minus x squared plus 4x and g of x equals to x. A parabola opening downwards and a straight line. So in this example, we'll try to solve for f of x greater than g of x. Now we'll discuss two different methods of solving, and these are the methods to solve inequalities. One of them will be graph. So using a graph you can solve inequalities. The other one will be algebraic solution, right? So the other one is algebraic solution. So let's begin with the graph first. We're given the function f of x equals to minus x squared plus 4x. If I have to sketch this graph, let me write down it in the factored form. I can take minus x common. I get x minus 4. So we get two zeros, one at 0, the other one is at 4. Maximum in this case, because it opens downwards, should be at midway between the two zeros. So f2 will provide us with that value, which is minus 2 minus 4, and that gives us a value of minus 2 times minus 2. So f of 2 is plus 4 for us, right? So that gives us the function f of x, which is a parabola. So let me sketch this parabola here. So we have two zeros, one is at 0, the other one is at 4. It opens downwards. So let me just sketch a graph first, and then we'll label it. So that is the parabola. Correct. Now in this particular parabola, 1 0 is at the origin, the other one is at 4, and the maximum value is right in the center, whose value is 4, right? So which is at 2, right? So f of 2 is 4. So that's how we get first function. The second one is g of x equals to 0. Now let's try to sketch the second function. G of x equals to 0. It's a straight line. G of x equals to x. It's a straight line. We can take 2 points. If x equals to 0, then g of 0 is going to be 0. And let us say 2. G of 2 is going to be 2. So we get 2 points. Joining these 2 points, we can sketch the graph of this particular function. So the first point is at 0, g of 0. The other one at 2, we get 2, midway between 0 and 4. So if I draw these, connecting these to a straight line, I get the function g of x. Right, so we have both the functions on the same graph, parabola opening downwards, and the straight line going through the origin. Now the question is, f of x is greater than g of x. What is that region during which f of x is greater than g of x? So it is this region, right? So that is the region where the parabola has higher values than the line, right? So our solution in this case will be from 0 to this point, and this point seems to be at 3. So let's write down 3 here for the time being. So if you do it on a graph paper, it'll be very close to 3. Let's take it 3 for the time being. And once we do algebraic solution, we'll get accurate value, correct? So we will see how to, from the graph we can actually get fairly good value. At times it is accurate, as it is in this particular case, okay? And at times it may not be, right? But from the graph, what we really do is we compare the y values. So when you're solving for f of x greater than g of x, you are actually comparing y values for same x value, right? So if y value is higher, then the function has a greater value at that point, right? So here you can see between 0 to 3, y values of the function f of x are more than the value of the linear function g of x. So that becomes the solution. Now let's try to solve algebraically. F of x greater than g of x. So what we can do is we can write down our function. Well, this equation can also be treated as f of x minus g of x is greater than 0. So both are same equations. At times, it could be written like this, but also like this. Both are same, right? F of x is minus x squared plus 4x is greater than g of x, which is x. Let's bring them together to one side. So we get minus x squared plus 4x minus x is greater than 0. Now we can combine the like terms. Minus x squared plus 3x is greater than 0. We can take minus x common. We get x minus 3 greater than 0. To solve this equation, what you can do is you can make table of values, correct? So let's make table of values to solve this equation. So we have two zeros. One is at 0, the other one is at 3, right? So let's analyze the intervals which these zeros divide. So one is at 0, the other one is at 3. So the zeros are at 0 and at 3, right? So let me write down here zeros for us. So we'll write zeros which are at 0 and 3, and then we will consider the test points and then the factors to solve it, right? I hope you remember your method. So we'll take the test points in the given intervals. Test points from minus infinity to 0 could be minus 1, from 0 to 3 could be plus 1, 3 to infinity could be 4, right? So you understand what so here what we are doing is we are checking the intervals, right? So intervals are, this interval is from minus infinity to 0, this is from 0 to 3, and then we have 3 to infinity. So these are the three intervals which we need to test for. Our factors are minus x and x minus 3. If I substitute minus 1, I get positive value. If I substitute 1, I get negative values. 4, I get a negative value. X minus 3 will give me negative, negative, and then positive. When I multiply these two, right, so when I do times these two, then what happens? In this particular case, it is negative, then it's positive. Here it is negative. Since we are looking for greater than 0, that is our answer. Positive value is within the interval 0 to 3, right? So our solution is that x is greater than 0 and is less than 3, which could also be written as 0 to 3, as we wrote last time. Correct? So that is how you can solve inequalities whenever two functions are given to you, right? So I hope with this you understand the methods. Go through this, and these are two common methods which we are going to use in this chapter of solving inequalities of combined functions. However, here is a question for you. We want to solve f of x greater than g of x. Can I rearrange this and write this as f of x over g of x greater than 1 and solve? So can I do that? So I would like you to provide me with suggestions that if I write this as f of x over g of x greater than 1, then can you get the correct solution? That is your question, right? If not, explain why, right? Of course, in this particular case, you will notice that g of x should not be equal to 0, right? So that is important because it's in the denominator. Perfect. So that value could be tested separately. But in general, if f of x is greater than g of x, can I solve f of x divided by g of x greater than 1 and get the same solution? So that is the question for you. I hope that will give you some challenge to answer. Let me know if there is a difficulty. We'll take this up in some video. Thank you and all the best.